Okay, hi again everyone. We're on page 19 of our statistics class notes, working in section 2.3. And on page 18, just to remind you real quick, we constructed this frequency table for a categorical data set. It's hypothetical biology class, students in our biology class and what class they're in, freshman, sophomore, junior, etc. So now what we want to do, instead of having just that frequency table, we want to construct this bar chart. So again, this was computed with StatCrunch, and we can get the bar chart displaying the frequencies on the left side here, the counts, right, of each class in the order we put into the table. So we can make this bar graph. We click on graph, bar plot, and then with data. Well, let me show you real quick again. Let me get over there. So here I have all that same data that I put into a StatCrunch spreadsheet. So just like we made dot plots, histograms, and stem plots for numerical data, we can now make bar plots. So I'm going to make a bar plot, graph, bar plot, and then I actually have the data. I don't have that summarized frequency table, so if I had the frequency table summarized, I would do with summary, but I'm going to do with data. And then what I want to plot is their class. And let's just leave it like that. Let's do compute. And that's exactly what I have cut and pasted into your notes. Okay. So here it is. Now, we could just as easily produce what's called a relative frequency bar chart. Now, notice that the shapes are exactly the same, right? For some reason, StatCrunch there's no inherent order to this as far as what's in here, like when you have categorical data, there's really no order, right? It doesn't matter what order things are in, and somehow it put juniors second, seniors, doesn't really matter, okay? You can imagine if this was eye color, brown, gray, green, hazel, whatever, it wouldn't matter what order it's in either, right? So order doesn't really matter with categorical data. That's just what StatCrunch did. Now, for relative frequency, instead of having the count on the side on the y-axis, we're going to have the relative frequency, right? That ratio I was showing you how to compute with the frequency table. Biggest thing is that the shape is exactly the same. Now, if I went back to show you how to do that, notice I have frequency here. That was the default mode. So I could go ahead and edit this again or create a new one, but I'll just edit it. So instead of doing a frequency, I can go to choose relative frequency. And I'll hit compute. And again, it's exactly what you have in your notes, but instead of having the count on the y-axis, I now have the relative frequency on the y-axis. Okay, a Pareto chart is a bar chart in which the bars are arranged from tallest to shortest. It allows us to quickly see what the most is. Now in this one, not too many categories, I can quickly see that unknown was the most. Even if I couldn't see it from my frequency table, I can see unknown has the most in it really quickly. But sometimes you want to arrange them from tallest to shortest, kind of order them. It can't be done in a histogram. Never can think about that in a histogram with numerical values, because the bins have to be arranged numerically. But since there's no order in a bar chart, I can arrange it in order. That's called the Pareto chart. I didn't stick it in the notes, but all you got to do is tell it to order by count descending. So let's go back and show you that. So again, now I want to actually give it an order here. So I'm going to go to options and edit it again. I want to order by count descending. I'm going to change it back to my frequency just because I like counts better than relative frequency to show this. So order by count descending, hit compute. And now it puts it in the order of tallest to shortest, right? I can quickly see the most here.